My name is Bayuh Asmamaw. I am from Ethiopia. Today, I will discuss about my research entitled Mapping and Associated Factor of Child Death and Mothers who Suffer in Child Death in Sub-Saharan Africa. I will start introduction part. Child are a valuable resource in developing countries like Sub-Saharan Africa, most countries of Sub-Saharan Africa countries. The primary goal of the people in Sub-Saharan Africa to raise children. Millions of children have higher chance to survival in 2020 compared to 1919. Approximately 14,000 children per day, or about 5 million children under the age of 5 died in the year only 2019. Most of the deaths of them were lay in my research area called in Sub-Saharan Africa. In Sub-Saharan Africa, the death of a child. In Sub-Saharan, the child is the grieving of mothers because it influenced by the culture, personality, lifestyle, family relationship, and the ultimate goal of the families as well as the mothers. Mothers lose their children's support, will unable to sustain themselves in retirement, and will forced to live in the streets. This study necessary for creation of programs in Sub-Saharan Africa of bereaved mothers whose children died at any age of age ranges. This study indicates the geographical location of mothers who suffer in child death and the predators of child death and mothers who suffer in child death. It is all about my introduction. Next, I will discuss in method parts. For this analysis, I used two different data sources. The first is demography and health survey, and the next is multiple indicator cluster survey. Both are publicly free and publicly free sources. In this study, included about 400,000 of women and 1.5 million children only from those mothers. And those mothers and children comes from about 17,000 clusters. These clusters in 474 regions. In general, in this study, include 42 Sub-Saharan Africa countries. For this analysis, I used two different dependent variables. The first one is women who lost at least one child or not, which is binary outcome. If it lost at least one child or not, it's binary outcome. And the next is the number of children who have died in each woman. Each is count 0, 1, 2, 3, the minimum of 0, the maximum of 13, which is count. In this analysis, women at fertile age, whose age is 15 to 49, included in this study. But the women who have not a child within this age group excluded from the study. Before beginning any intervention or any analysis, the data from all countries are compiled into a single data set, not individually analysis. It is aggregated. For this analysis, I used two different models, the spatial model and the factor analysis model. The spatial model indicates the location of the burden of the mothers who suffer child death, the location at the highest burdens. And from those area, which group of the pupils are more affected from where the community indicated by the factor analysis. The first in the spatial case, the hotspot analysis. In the hotspot analysis, used to identify statistically significant spatial clusters, hotspot and cold spot. In this analysis, used to the area based. The area comes from it is regional or province or admin one based analysis prevalences. For this analysis, I used GeoGIS. The next is the second spatial scan analysis. In the spatial scan analysis, higher aggregate concentration of the intents were included in the circular windows. In the circular windows, this is Poisson models, used to Poisson models. In higher aggregate, based on their clusters, based on cluster, number of cases and number of samples, analyze the higher concentration in the circular windows compared to their surroundings. The last is the spatial interpolation. The spatial interpolation was used to measure and measure area, predict and measure the based on the neighbors of measured area. For this analysis, I use Saga GIS. In all three analyses, used open source GIS. The next is factor analysis. In the previous, I shows in the location. The next is from this location, which group of pupils are more affected. For this analysis, multi-level regression, multi-level logistic regression, and multi-level Poisson regression used. Due to hierarchical nature of the DHS and the MIS data can use level analysis because individual needs to within household needs to within community needs to region needs to within countries. So such type of data used 2, 3 or more level of analysis, but I used only 2 level of analysis. The lower level is household level or maternal level characteristics, and the higher level is the community level characteristics. A multi-level regression analysis was performed to evaluate factor linked to maternal and community level characteristics. In this analysis, I used 2 different sub-models. Then first is negative binomial regression for number of child deaths. For number of child deaths indicates count. The count is treated by Poisson regression. When the variance is greater than the mean, which is called over-distribution. During over-distribution of Poisson regression treated by negative binomial regression. So my data is the variance is greater than the mean, so I used negative binomial regressions. The second is binary logistic regression for maternal suffering of child death, which is binary outcome. The mother will suffer at least 1 child death or not, which is a binary. So I used binary multi-level, mixed effect multi-level binary logistic regressions. For all findings, weighted methods implemented because both DHS and MIS have its own weighted value for each individuals. It is all about my method sections. Next, I will discuss the results. The first is spatial epidemiology. In Sub-Saharan Africa, in a woman, in average, each woman in Sub-Saharan Africa has 3.8 children. Out of 1.5 million children, about 180,000 of them died, or 12% of the children who born from Sub-Saharan Africa, including in this research, were died. And those children come from about 110 of women. The women in Sub-Saharan Africa, out of 4 women, at least one of them suffers at least 1 child death. From mothers who have experienced child death or who lose at least 1 child death, in average, loses 1.66 children. This bar graph and the confidence interval indicates that mothers who suffer, the percent of mothers who suffer in child death in each country and in Sub-Saharan Africa. In Sub-Saharan Africa, 27% of mothers suffers in child death, or out of 4 mothers, at least one of them suffers in child death. The maximum contributions of mothers who suffer in child death found in Niger. Mothers from Niger, approximately half of them suffers in child death. The next is Burkina Faso and Chad. Mothers from Burkina Faso and Chad, out of 5 mothers, 2 or more of them suffers in child death. And the lowest percent of mothers who suffer in child death found in South Africa, Sao Tome and Principe, Somalia, which accounts out of 10 mothers, about only one of them suffers in child death. The spatial epidemiology by residence. This bar graph and the confidence interval indicates that the mothers who suffer in child death by residence. The red color indicates the urban and the green color indicates the rural. In average, in Sub-Saharan Africa, 31% of mothers from a rural area and 20% of mothers from urban area suffers at least 1 child death. The maximum contribution of mothers who suffer in child death found in Niger. About half of in rural area. About half of mothers from rural area in Niger suffers at least 1 child death. The next is Chad and Burkina Faso. Mothers from Chad and Burkina Faso, out of 5 mothers, 2 or more mothers suffers in child death comes from rural area. And the lowest is in Somalia, Sao Tome and Principe, South Africa, which accounts about 1 of mothers out of 10 mothers from rural area suffers in child death. In urban area, the maximum contribution of mothers who suffer in child death in urban area found in Chad, Liberia, and South Sudan. Out of 10 mothers, only 1 of them suffers in child death. Only 3 of them suffers in child death. The next indicates that a mother whose age at the end of the child breathing, a mother whose age 45 to 49. In average, out of 2 mothers, half of them were in Sub-Saharan Africa suffers in child death. The maximum contribution of mothers whose age 45 to 49 or is found in Niger. Out of 5 mothers, 4 of them were suffers in childhood. The other is the next is Burkina Faso, Liberia, Chad, Rwanda, Burundi, Uganda, Ethiopia, which accounts out of 10 mothers, out of 5 mothers, 3 or more of them were suffers in childhood. The next indicates the spatial epidemiology. The spatial indicates that the first is based on polygon or regional or province based or admin one based prevalence based. The first is the prevalence, pure prevalence. The red color indicates a mothers who lives in this area, 36% of them or above them were suffers at least one child death. And the next, the orange color indicates a mothers who live in this orange color is 26 to 35% of them were suffers in child death. The next indicates that used geoda, which is indicates that the high or the hot spot and the cold spot, which indicates the red color and the high value, which compared to their surrounded. Most of them found in Western Sub-Saharan Africa, some and the lowest or the cold spot indicates that found in Southern Sub-Saharan Africa. The next two indicate two maps were from based on point data or based on cluster point data prevalence, cluster per cluster values. The first indicates that calculates the number of cases in the cluster and the number of samples in this cluster. In the circular windows indicates the higher concentration of cases found in these circular windows compared to their surroundings. The next is in the cluster prevalence. In the cluster prevalence indicates that the prediction of unmeasured area based on the neighbors for measured area. So in this both results found in Western, most of Western Sub-Saharan Africa, Central and Eastern Sub-Saharan Africa were more affected or more continuous mothers who suffer in child death. And the lowest is found in Southern Sub-Saharan Africa. The next indicates that factor analysis. In the previous, I shows the location of the mothers who suffer in child death. This indicates that which group of mothers or from which community were more affected from that high affected area. The first is adjusted odds ratio. The adjusted odds ratio comes from the binary outcome of the mothers who suffer child death or not, which indicates the red colors in this forest plots. This vertical line is on the one. From the value is or the forest plot indicates to the left of the one, the reference is more risk compared to the others, and in the right, the reference is protective. For example, and the next adjusted incidence rate ratio indicates the number of child deaths, which is the count outcomes. And this pie chart indicates that the number of the percent of mothers who suffer in child death by the number of child deaths. In the red color, 4% of mothers who suffer 3 or more child deaths, and 6% of mothers who suffer only 2 child deaths, and 10% of mothers who suffer 2 or more child deaths. Conclusion. It is all about my results. Next in the conclusion. Almost all area of Western Sub-Saharan Africa and some area of Central in Eastern Sub-Saharan Africa like Ethiopia and others